Okay, so we are going to get started. Yeah, hopefully for also those that are online. Yeah, so we will talk about operating OpenSearch in e-commerce at scale. Yeah, so this is the third day of this conference. So our talk is scheduled for this morning. We are Adelean. We are experts in search technologies. We built an e-commerce search engine that's called A2. We integrate OpenSearch, Solr, Elasticsearch also since 2010. So yeah, this talk is about tips and tricks on operating OpenSearch in e-commerce. Okay, so we will talk about a little bit of our background. We will address some specific e-commerce search features. We will see indexing at scale and then cluster-specific tips and tricks. Also monitoring and observability. So the tips and tricks that we will give today are taken from our experience, which comes from some big deployments where either we developed the search engine or we are operating those. So some of these search engines are just a few examples. Some of those are still operated by us. Yeah, you have large retailers that have many physical stores and e-commerce stores also. You have retailers that have a lot of languages across their database, also a lot of different websites and different search services. And also marketplaces. So Fnac.com is the third marketplace in France. Used to be #1 before Amazon got in, but yeah, it's a huge e-commerce website. So 15 tips and tricks. So this is #1. So we are addressing especially ops people. Usually our talks address developers, and we give advices for developers. But in this case, we will focus on scaling and on mostly DevOps and operations. Okay, even though all these goes back to development. So the first one is about auto-completion. So as an ops team member, if you see that the auto-completion is based on only one index, then you should question the developers. And typically this auto-completion screen should be backed by at least 4 indices, 4 different indices. So the idea is to create one index for each auto-completion type and not use aggregations, for example. If you take, for example, #2 and #4, you could provide them only based on the product index by using aggregations. But when you're implementing an auto-completion service, you need to be fast. Each character that you type is a call to your search API, so the response has to be really swift. So yeah, you should have at least 4 indices in the back of this screen. We gave yesterday a talk about plugins, and we actually showcased how you implement, for example, #2 and #4 with just a plugin. So it's pretty straightforward. Okay, so.
And since the auto-completion is the first step that the clients will use to contact your search engine, so you need to have very fast response, and so in order to have fast response, you need to have small indices, so optimized indices. So in this case, we will only show, for example, the title in our response, so you don't need to store all the other attributes. So as we said, you will have a specific index for your auto-completion use case, then you need to store the minimum in your index. because we know that OpenSearch in general will store the source that you received, and it will also, it is generous, so it will create the text and the keyword attributes for every field that you will receive. But in order to optimize your index, you don't need to store the source, and you don't need also to store the attributes that you want to use. In general, you will only store the attributes that you will need for your search, so only the searchable attributes, maybe some attributes that you will retrieve in the response to show them in the front-end application, and also just the attributes that you will need for faceting and for sorting also. And in order to do that, you can also disable dynamic mapping. So in this tip, we advise you to use always explicit mapping. So you won't have surprises if you have another attributes that are coming and they change the type, etc. So you need to handle them very well. So you avoid also the surprises and the errors in your request. And in this case, you can use the parameters dynamic mapping false, so you will have always specific mappings that you will handle. The only thing that you should pay attention to it when you use dynamic mappings false and do not store the source, if you need to do a reindexation operation from your index, you need to store the source. So you can do some reindexation based on the data in your index. And the third tip is don't worry about function scores performance. It is a very powerful feature that is given by OpenSearch that you can use to boost products and also do some personalizations. Since e-commerce is not always about just lexical match between the query and the products, but you need also the intelligence of the relevance and also the business needs if they want to promote some products or do some merchandising, for example. So we advise you to use function scores. Some people don't want to use it a lot because they are afraid of the performance in the query time, but in our case, we have here an example of, it's not very visible on the screen, but it's done for this purpose.
It's a real-world example.
It's a real-world example that we use. This is just a small request. We have a huge request that contains more functions than this, and we don't have problems of performance in the search. So don't worry about their overhead. They are very performant if you use them wisely and if you keep them clean and have functions that are well written so that they won't impact performance. So in this example that we have some manual boosts. We have also promotion products that we will put in the first positions. We boost the products that sells well in the last 7 days, a little bit more last month or last 3 months. Since this will penalize the new products, we want also to promote them so that the clients will see them to buy them also, so we have new, fresh data. We can boost or deboost some categories for specific requests, and the most important is that we can also use it for personalizations. We have other ways to do personalizations, but the function scores are the future that you can use also to do personalization.
Okay, so tip number 4 will bring us to tip number 5, which is about cluster state. So the idea is to keep the settings and mappings of your indices as smallest as possible. And there are also some operating issues that are solved by this tip here, which is keep the lists, for example, synonyms, in files. In some deployments, we might have so we have like 1,000 synonyms, and if you deploy them for every index, maybe the synonyms apply to several fields, then your mapping and your settings become huge. The cluster state increases also in size, and it's less performant. Now, it's true that it's less convenient to have synonyms in files, especially when you deploy your OpenSearch instance in the cloud or on Kubernetes, or you're using a cloud service and you don't have access to the file system. That is true. In this case, you can use, for example, a plugin here that will store synonyms in indices. Okay, so they are not stored in files, they are stored in indices, but they are external to the mappings and settings. So this is this is better, and the cluster state will be smaller, and yeah, your search will be faster.
So this tip comes from our experience. So we had a huge list of synonyms that were used in a lot of indices. So in every index, we store the list of synonyms in the settings. So it adds some overhead on the nodes, since they have the settings and the mappings in memory for some indices, and also a little bit of storage. So this duplication increased the cluster states that add overhead also for the management of the cluster. So it slowed down some operation. And also the benefits of having them in external file on an index is that when you do some changes to your synonym lists, you want it maybe to be visible directly in the front end. But it's not possible, since you need to reindex your index so that you will see them, you will see the change. So maybe sometimes it takes a little bit more time, or you need to close or reopen the index. But in this case, you don't want to have a downtime service. So you can't close an index because it will not receive requests after that. So the advantage of having them in a list of files, for example, is that you can do some versionings for the files, or maybe use, if it's not convenient to copy the file in every node of the cluster, you can also just use the Telecent plugin and have them in a synonym. So it's shared between all the nodes. And in our case, we did use the synonym in files so that we can use them in some analyzers that are search analyzers. So when the business users change their list of synonyms, they can just apply these synonyms and then refresh the search analyzer. So they are visible directly in the front end. And also, you don't need to reindex, or maybe need to close or open the index. And it also improved the performance of our clusters, because we had a huge synonym list, and when we removed them onto a file, the cluster states decreased, and then the clusters had more overhead and more memory to respond to the queries. So yeah, in our case, it improves our performance also.
Okay, tip number 5 is a trade-off between doing things in the query and preparing the data at index time. So it's running algorithms at query time or at index time. On the right-hand side, you have a sort that's done on a field that represents the promotion type. So as the promotion type is not like sortable, because it's just a label, you cannot sort them alphabetically or stuff like that. It's just an ID. So you need an algorithm that will say, okay, that promotion type is the first one, the other one is the second one, and so on. So of course you can do that with a script, for example, in the query. This is the right-hand side. But it's better to do this computation at index time. So you see on the left-hand side, the same algorithm. It's actually the same code, roughly, just a few modifications because of the syntax and because we are not in the same context. So we are in an ingest pipeline at index time, but it's roughly the same code. So the algorithm is executed at index time. So at index time, we prepare the data. And then at search time, we will just need to sort on a field that's optimized for sorting. It's cached, it's optimized for sorting, and so on. Okay, so prepare the data at index time, run algorithms at index time whenever you can. The next tip, number 6, it's about nested and join tabs. So the nested type, especially join also, is a very powerful feature, and it's used a lot in e-commerce use cases. It's very handy. That's true. But the truth is that your infrastructure is like oversized if you use nested queries and nested aggregations and the nested type. Because nested queries are literally 10 times slower than their flattened alternative. So the flattened alternative sometimes is straightforward. Sometimes is like you need to develop, you need to like model the data differently. Sometimes is more development. That is true. You need to put more effort into data modeling and development. But yeah, you get faster queries if you do not use nested. And the join types, the join queries are even 100 times slower. Okay, so you use them wisely if you use them. Here's an example of how you can flatten the data structure. So this is something we see often. On the left-hand side, you have a modeling that actually lists the attributes that you find on the product. Usually you find like tens of attributes for category, for one category. And if you have like different categories because you have a marketplace or you have a large store with different types of products, you may end up with like maybe thousands of attributes globally, so for all the categories. That is true. So it's convenient to group the attributes like this: name, value, name, value, name, value. Okay, but we prefer the other alternative, which is to flatten the attributes, to name them, even though that brings you to other problems, like you will explode the number of fields, you will need to increase the limits of OpenSearch elsewhere. But yeah, the queries will be faster, nevertheless. Okay, this is another use case where it's more complex to flatten. Okay, you need some development here. So the use case is that you store in the index products that have offers on them, so variants. So in this example, you have two variants, with size and color. And it's true that to flatten this, it's more complex, okay? But you can still, if the variants do not differ very much, they have like 2 or 3 attributes that characterizes them, you can do hacks like this one, where you concatenate the features and you flatten like this, okay? You need to post-process the response in order to display the facets and all that, but it's something that we do in order to speed performance, and we gain like 10 times the performance time.
So in case you did all the work in the data modelization to flatten the products, you will have another problem in the search response. So you have the same product, but you have 10 variants of the product. So you only want to show it one time in the response and maybe add some icons on your front UI to say to the clients, oh, you should pay attention. This, for example, in this case, this T-shirt have several sizes and several colors. So maybe if you go to the product card, you will see all these offers of this product. So in order to do this, you can use the collapse parameters in the search query based on a field. In general, it's the product ID field, because maybe also you will have marketplace use cases that we see very often, that you have multiple sellers in the marketplace and they all sell the same product. So you can collapse on the field products ID. And our tips for this one is that you could use collapse. It performs very well, but in the other side, you will have only one product in the top of your search results. You won't have all the other offers when you use the collapse. But in order to have all the other offers of your product, you can use the inner hits, but we advise you to avoid using it because it's very, very slow. It decreases a lot the performance of the search, especially if you have a lot of inner search requests and also a lot of variants in your data. So our tip is use collapse to group your data. You should just pay attention, because when you do collapse, you will have its total, so the total of products that you have in your search results, it will be the number of the products with all the variants counted in it. So it will not recount the total hits after your collapsing. So in order to address that, you can use cardinality aggregation so that you will have the exact counts or near exact counts of the IDs after the collapse. And as the documentation of OpenSearch says, the collapse parameter affect only the search results, but it doesn't affect at all the aggregations. So if you have some counters in your aggregations, you should also use this cardinality aggregations to have better counters. But the problem is if you use it and you have several aggregations in your search request, you will see a spike of CPU. So maybe you should use less aggregations, or maybe just don't pay attention to counters. But it's a trade-off to find. And our alternative, since we said to avoid to use inner hits requests, our alternatives that performs very well at scale and that we use very often in some projects is that we will do the first request with the collapse parameters, and we will only retrieve the product IDs that we found in the requests. So for example, let's say I have a page of 120 products, or maybe just 13 products in the first page. So I will retrieve their IDs, and after that I will send a query with a filter on these product IDs, and I will have an aggregations, term aggregations on the product IDs, and for each product IDs, I will have top hits sub-aggregations that will give me the variant of this product. So you will have the products at the first time, and you will also have all the variants in the top hits aggregations. And you can also do some fun things. For example, if you have a marketplace that sells the same product multiple times, you can add a sort parameters to propose the cheapest vendor first and then sort them by price, so that the user will find the most convenient offers in your marketplace.
Yeah, so collapse, cardinality aggregation, and as an alternative to inner hits, top hits aggregation, and a second query with top hits aggregation. So, yeah. And you have a fast query. Next tip is to unify your data model. So especially when you have a lot of different data sources and marketplaces and stuff like that. For example, a retailer that's selling food, groceries, electronic devices, and also home appliances, for example. They are inherently different. By their schema is different. It's very convenient to just like leave them as they are, and then do the query on top of 3 indices that have different schemas. It's feasible, but we recommend to do some uniformization there and to have a common schema for your products, no matter where they come from. So at least for the searchable fields, for the main facets, for the sortable fields, they should have the same name, the same mapping, even though they are in different indices. Okay, so yeah, some data modeling there in order to keep your schema unique.
So yeah, it can allows you also to do some multi-index search requests if you want to split your data on multiple indexes and search all of them at the same time. And also, we should pay attention to the deleted documents, because when we are in e-commerce, we have a lot of stock movements. So there are products that come and go every time out of stock, and then they come back. So we delete a lot of documents and reindex a lot of documents. But in reality, they stay on the segment. So they are not really deleted. So you have your storage that increase, and you also have query latency that is impacted if you have a lot of deleted documents.
Even if you do an update, like in all NoSQL database, an update will actually create a deleted document.
Yeah. So in OpenSearch, you have available tools to improve that. So you have first merge, that there are several merges that OpenSearch does automatically, but if you want to force it, you can use the first merge API. But the problem is that if you want to do it, you should do it on an index that does not receive write requests. Because if it's not the case, you will have a huge segment that OpenSearch won't merge after that. So it will just grows. And what we advise is to use reindex API, so that you keep your old index that is receiving requests and write requests, and create another index from it, and then reroute the delta that you received between the start of the index and the end of it to the new index, and use aliases so that you don't have the downtime. So you can remove the alias from the old index and add it to the new one with the alias API, and it's atomically. So you don't have no downtimes between it. And since And as you see on the graph, it's a search response from one of our platform search engines.
This is a cluster that we currently operate, and it's a real-life example.
It's a real-life example. So we have, we will say, less traffic at night. So we will say that search response time increase over time, and we will see every day between midnight and 2 a.m. we will do a reindexation so that we will have fresh new segments, and you will see that the search response time decrease. And when we receive a lot of data indexation by the start of the day, it starts to increase. So yeah.
So best performance is right after the reindex when you have 0 deleted documents. And then throughout the day, the deleted documents increase. Of course, you also have the traffic that increases, but the deleted documents increase because you have movements on the product, so you have stocks that are updated, prices that are updated. So the performance of the queries decreases, okay? You have more time per each query. And yeah, right after the reindexing, boom, 0 documents, best performance.
So in this case, we do it every night, but we also have some cases where we do it more frequently to have better performance. But you also should pay attention. If you have a lot of requests, a spike of requests, we don't advise to do it in the same time because you will also penalize your clusters. So you do reindexation, and a spike of requests at the same time is not very ideal.
Okay, so we mentioned the cluster state earlier. So the cluster state, it's actually a JSON file that combines all the settings and mappings of all the indices. And there's an API that gives you this JSON file in OpenSearch. That's the API, it's called just _cluster/state. So this API is gives you an idea of how big is your cluster state. The idea is to keep the cluster state size as low as possible. There's a limit for the size. So the limit of 8 megabytes has been cited several times, but actually the limit depends on your deployment, your infrastructure, your queries, your users, etc. So the limit is your limit. But the idea is to keep this cluster state as low as possible. So you have the synonyms, stop words, and all the other lists that you can put out of the cluster state in files. That's one thing that you can do. You can disable the dynamic mapping, as we saw. And also, you can deploy several smaller clusters instead of adding nodes to an existing cluster. For example, if you need let's say at Christmas time or when the traffic explodes, you need to add 3 nodes to your 3 nodes cluster. Instead of adding 3 nodes to have a 6 nodes cluster, it's better to create a second cluster with 3 nodes. So you have smaller clusters with smaller cluster states. They will perform better.
Yes, and since we talked about all the limits that you shouldn't go up, it's very funny, but we will say that the tip number 11 is that you can go over the limits. So we talked about limiting the cluster states, for example, but you can go up if you want to add more shards per nodes. The limit is 1,000. There are some hard limits in OpenSearch, but you can go further. For example, in our case, we have some small clusters that will hosts more than 1,000 shards per nodes, but it's a trade-off that you can do. You can add them, but you should not increase them dramatically. So you can just add some shards or some nodes and test if the performance suits you, if you respect your SLAs. So you can do it. It's not forbidden. And the same thing also for the number of fields. In some cases, we cannot just use 1,000 fields in a clusters, in an index. In some use cases, you need to handle all the fields. So yeah, just increase the limits. You should do some tests if you don't lose performance or if it suits you, and then you can upgrade them.
If you remember the nested flattening there, if you flatten the fields, then you'll get more fields, and the cluster state increases. But yeah, you should do a trade-off there and see where the cursor is.
So you will win performance on the search request sides, but you will have more cluster management overhead. But if you meet the performance needs, it's okay. And at the same time also for example, for the number of clouds in a Boolean queries, you can increase them. So in some cases you will have larger queries, but each query will consume, of course, more memory, but you can reduce the thread numbers, for example, for the search, so that you will have just few queries in concurrent, and they will be very fast, and you will treat other queries that are arriving. But you should do it carefully also. For example, if you have a lot of clauses in Boolean queries, if you do, for example, a Boolean query with a lot of should clauses, it will be very huge. But if you use terms, for example, instead to filter, it is more optimized. So you can go above these limits, but you should do them very well, and you should optimize also your queries or your data in order to do that.
In any case, this is a list of typical configuration that you will maybe tweak to go over the limits. Yeah. So these three numbers here are usually tweaked in e-commerce. Yeah. Tip number 12. We suggest that replicating the indices on all the nodes, so all the nodes in your cluster are identical, strictly identical, is better in an e-commerce deployment. So, of course, if you're indexing logs and all that, just one copy of the data is enough. But in e-commerce, it's important that the query is fast. Okay, so the indexing might be slower. Okay, that happens, but the query should be fast. So if the data is located on every node, then it is more likely that when a node receives a query, it has everything it needs to respond to that query. Okay, so replicating the data identically on all the nodes in your cluster allows you to have nodes that are independent. Even when you do maintenance, for example, if you take out a node, you don't have resharding and reallocation that happens. And yeah, the two nodes will technically have the same performance there during the maintenance. Okay, and as for sharding, yeah, that's a large subject, but yeah, we usually start with one shard. Rarely use more than one. It can happen, especially when you want to index faster and to replicate the index pressure on more than one node.
Yeah, so, and tip number 13 is to debug and profile your queries. So when you have some queries that are very slow, in this case, you can use the profile API, so you have the performance to find the bottleneck of your query performance. So maybe you will find that you have some aggregations that you use that are not very performant, and you could tweak them. And the second one is to explain the relevancy of your search query. For example, when the business needs will just ask, oh, why I have this product here in this position? Why I have this product that is not in the first position, for example. So you have the explain API that helps you to understand the sort and the ranking of your search response. And we advise you also to have, for example, some UI like the search relevance workbench in OpenSearch and all the new features that can help you understand your relevance. So in this example, we have a screenshot from our business console that we provide to merchandiser users. So we will see here the explanation, for example, of our requests that uses the lexical match, which is in the lexical score part, so that we know what matched in these products and how this score is calculated. But we have also all the boost scores that is just in the first table that will show, for example, like the function score that we saw earlier. So we see that this product is in this position because this is his lexical score, and he has also a boost, for example, because he is sold in the last 7 days, and also it's a new product, etc. So we help them understand better the position of these products. And just a little tip on monitor and alert with the OpenSearch. You can of course, use OpenSearch observability to index the logs and also to have dashboards to monitor your stack, but you can also use open source other alternatives. In our case, we use a lot Grafana and Prometheus, so you just have, for example, some pre-built dashboards that you just need to import. It's like a JSON that you import onto your Grafana, and you connect Prometheus with your OpenSearch stack, and it works very well.
So monitoring and alerting in e-commerce is very, very important. So, and luckily, OpenSearch can also do that. So it's
you should be proactive and take actions very fast.
Very convenient. Okay, so last one about vector search. So vector search is the buzzword that anybody says. So I think we have a talk on Gen AI and vector search in parallel to this one in the other room. So in e-commerce, it is a feature, but it's mostly a buzzword. There are 3 use cases for vector search in e-commerce, and yeah, there are like just these three use cases. If you use vector search as your main search in e-commerce, you will have a lot of noise, okay? Because vector search gives you nearest neighbors, so gives you points that are nearest neighbor to your query. Okay, so if you search for apples, for example, you will get apples and bananas because they are close there. But you might also get computers because in the vector space, the model placed the Apple brand next to apples, for example. So you will not get only the relevant result, you will get also a long tail of further away neighbors, okay? Because this is how vector search works. It will give you the nearest neighbors, but the nearest neighbors can be far away also. So we recommend using vector search for zero results queries, so as a backup to your lexical search and your function score tweaking so faceting and sorting and all that, that's available. So e-commerce data is usually highly structured. Vector search is less relevant. Another use case for vector search, which is definitely the use case, is when you have multimodal search. So in this case, you should use vector search. If you want to search for your products using an image, then yeah, you need vector search. If you want to search for images using a text, again, this is multimodal. So this is maybe the main use case for vector search in e-commerce. And last use case is personalization. There are other alternatives to personalization. Don't necessarily need vectors and embeddings, but it's an alternative for that. So this is taken from Trey Granger's talk. He gave a talk yesterday also on this topic. Whenever users have a basket and a user profile, the vector search can help there. And that's it for our presentation. I just want to emphasize our other talks that we had in this conference. So you had this one, which was on Gen AI. So it was on the first day. You can look at the video when it's out, and you also have the slides there. We took some slides for this presentation that we did yesterday on plugins. For example, how to implement the auto-completion very, very easily with a plugin that we showcased. And if you need the slides for this presentation, they are uploaded on the schedule website. And that's the end of our presentation. Thank you for your attention. Yes. I'm sorry, can you repeat?
Apply them at search time or at index time?
Yeah. So the question was if we apply synonym at search time or index time. So we use graph synonyms And for those, you have to apply that at search time. There's also an advantage for that, is that when you change the synonyms, they can be visible right away. After the reloading of synonyms, so you have to call the reload API, so the synonyms get reloaded in the mapping from the file or from the index. Yeah. You can also change the mapping, but you need to close the index and reopen it in order for the synonyms to take action. But yeah, graph synonyms, you have to use them at search time. Yeah. And it's also a vector of, we mentioned the Boolean queries and the limits of the Boolean queries that you should increase, because by default in OpenSearch you can have 1,024 Boolean queries in the same query. When I say 1,024, it's Lucian queries, okay? When you have synonyms at query time and they get expanded, if your query is kind of complex, you have some Boolean query with must and should and some function scores there, and then you have synonyms that get expanded, you have a combination that can go beyond 1,000 Boolean queries. So that's the drawback, but you should just increase that limit and it works. For some deployments, we have literally thousands of synonyms that are defined, and it works, even if it's query time. Thanks for the question.
Can you elaborate a little bit more on the first tip, when you say that for autocomplete, you recommend having separate indexes per type?
Yes, so the question is, for autocomplete, why we recommend to have more indices. Yeah, so the idea is, for example, if you take this example here, this screen, which is an autocomplete screen, you have products and you have categories. For example, just let's take 2 and 4. You could implement that with just one index, which is the products index, and an aggregation on categories. Okay, it could work. It's kind of difficult because you need to do auto-completion on categories, so it's kind of tricky, but it's not the fastest way at query time. Okay, because at auto-completion, you type a character, you send a query to the server, and the answer has to come back in like 10 milliseconds maximum. Okay, so you have to optimize every bit of module that's there, and typically for this, you need 4 indices.
So the UI is making 4 calls in parallel?
Either the UI is making 4 calls in parallel, or the UI is making 1 call, but your backend makes 4 calls, 4 queries in parallel. You can use multi-search, M-search, so you have just 1 response if you want. But yes, there are 4 queries that are independent. Either you send them in parallel, or you use M-search, and it's OpenSearch that will parallelize them.
And you can also have custom plugins like we showed yesterday, so you call just your custom endpoints and it will do all the requests and merge the response. So you have a custom response also.
So one plugin, we showcased 6 plugins yesterday. One of them allows you to just send the products to your products index, and the categories index is created automatically. And then the same plugin gives you a query that actually gives you this result. You query the products index, and it gives you products and categories in the same response. So, yeah. Well, storing the synonyms in a file is part of the base functionality of OpenSearch. Well, when you're on Kubernetes or on a managed service, you don't have access to the files, and it's more complex to do that. That's true. So you have this plugin here, which is open source, that allows you to do the same thing with an index. And hopefully this feature will be integrated into the core code of OpenSearch, so it will be available by default. So the first one is synonym. The first definition there is synonyms in the mapping. So if you have 1,000 synonyms here, like 1,000 lists of synonyms, this can be huge. The second example, you have the synonyms in the file. If it's a managed OpenSearch server, you don't have access to the disk, so it's not a way of doing it. The third one, the synonyms are in an index. And you can also like manage this index, and you can, the plugin we showed yesterday allows you to, it has even a graphical interface that will allow you to send synonyms to this index and so populate the index. And this way the mapping is short. And all the 1,000 synonyms are in this index, in the dot synonyms index, for example, in this case. Okay, so thank you for your attention. Thanks for the questions, and yeah, see you around at the conference. We still have a half a day to go, and yeah, see you next time.